if you can tell us a little bit about the journey that you've made and where you've come from, and also a little bit about the technology that you're developing.
Yeah, no problem at all. I hope everyone can hear me, and thanks for the opportunity to speak today. So H2Go Power is a hydrogen storage technology company. So we kind of join up where you generate the hydrogen all the way to the end user. So we've got two products that we've developed. One of them is sort of hardware based, and the idea is you're storing hydrogen in materials. It's an alternative to compressed gas. So it's safer, cheaper, and more dense. And we know that a lot of hydrogen projects, the barrier to getting them deployed is through the hydrogen storage. So that's kind of what that's unlocking. We also have a software product which we use to, before we even build a site, optimize how big, say, your electrolyzer needs to be, how your storage. It's like a data-driven decision-making tool. So it helps you understand what the financial metrics are, but also it's a live platform that helps turn things on and off to make sure you optimize your hydrogen hub most efficiently as possible. Now, with our solid-state storage, it's basically a containerized solution, and we're deploying it for industrial centers, for hydrogen refueling stations, and for heating applications. And we've got our first-of-a-kind demonstrator project up in Orkney in E-Day. So we're plugging it it'll come into commission early next year, and we're plugging it into an electrolyzer, which is generating hydrogen by wind and tidal power. And then we're then distributing that gas around the island. So it's sort of a safer, denser way of storing hydrogen gas. And yeah, you talked about where we came from. So it started back when me and my co-founder were at university, and she had this really cool innovation. We both are in chemistry. And then we basically spun out from the University of Cambridge. They had like innovation programs there, and then but we got some funding to develop it in London at Imperial College. We started off with a desk, or started off working out our bedrooms. Then we started off with a desk where we could start rapidly prototyping, and then we're now based in West London, and we've got just over 20 employees. And it's a really exciting time for us because we've spent all that time developing the technology, and now we want to get the technology out there to be commercialized and for people to use the benefits of it. And yeah, helping unlock some of the problems that are associated in the hydrogen industry to do with storage.
Okay, well, we'll talk about the kind of next steps for you in a second. So Luke Tan, super critical.
Same question?
Yes, please.
So maybe I'll start with where I come from and why hydrogen's sort of been part of my life. I did chemical engineering at university and basically working in hydrogen for my entire career. Initially I was a process engineer working in designing methanol plants which use hydrogen, and a huge off-taker of hydrogen today, taking natural gas, breaking it down to hydrogen, carbon monoxide and CO2 and producing methanol. But then I transitioned my career to something more clean. So I went towards hydrogen fuel cells. I was actually at the opening of this ITM motive station about 5 years ago. But I was fortunate enough to see the growth of the industries in other sectors or other areas of the world, like China, for example, and the US, where fuel cells were really taking off in specific applications. But none of those applications actually use hydrogen from green sources. They were all being produced in huge amounts in the middle of nowhere, and then this hydrogen was being transported into cities to be able to actually reduce emissions at use rather than at source. And the main reason, and the only reason, was cost. And I was determined to try and find a way to reduce that cost. And my paths crossed with my co-founders actually during the pandemic, where I was initially messaged on LinkedIn about an interesting idea, and we weren't allowed to meet up for about 3 months, and then we went to a car park to sign an NDA on a roof and walked 2 meters from one another for 2 hours around a park while we talked about the idea. And there I sort of transitioned my existing career into a startup career. And that's where Supercritical was born, really. They had a really great idea for reducing the cost of green hydrogen. We spent over a year to sort of finessing that, looking at alternatives and validating that idea against validating that idea with industrial users. And we started developing what we call supercritical water electrolysis. And that means using high pressure and intermediate temperatures to reduce the amount of renewable energy required to produce high pressure, zero emission hydrogen, which is ultimately how the industry needs it. So yeah, that's how we got to where we are.
Okay, and just before we ask you more about the companies, what really commits you to this industry? What is it about this industry that really fires you in the mornings? Luke,
Sure.
Chan.
Well, it's just really exciting. You know, I mean, I think genuinely this is the first time in decades the energy industry has been really challenged. And you know, when I went to university, people weren't looking at, but they weren't really looking at the opportunity for change. You know, the chemical engineering sector hadn't shifted for about 50 years. You know, they were working on petrochemicals, everything was pretty bog standard. And now we've been set this deadline for the net zero in 2050, and people really have to start thinking outside the box. We started Supergrid School, and we had one big challenge, and we've uncovered a lot of other challenges. But all of those challenges are opportunities for innovation to allow us to find out new things, explore push the boundaries. So for me, it's just an exciting time to be an engineer and an exciting time to actually develop something new.
So I'd like echo a lot of those points. And like as a scientist, I was always interested in the initial technology. But and we started the company about 8 years ago, and we actually got a lot of pushback saying, well, how does it compare with batteries? But what we've discovered today is that obviously hydrogen has a few more nuances, and it's one of those fuels that can cross sort of 4 energy verticals between industrial uses, for heating, for mobility, and for power. So it's one of those things, because it can cross so many verticals, you can have benefits so many industries for those, like and reduce carbon essentially.
Okay. Now, just thinking forward, what key elements do you need to actually take your businesses forward? What is it that you're worried about that you can't access at the moment, and perhaps this audience can help you with?
Happy to jump in there. So actually, one of the really key things for us at the moment is investment. So we want to move quickly, and we want to hire people and grow the company. So and so we can get our projects out there. So the number one thing for us is definitely getting that investment in so we can grow quickly. And that kind of leads on to the other two things, is getting the right people in, so for execution of the projects, but there's also convincing the people that these projects are right, and that involves government and industry, and then it's really the projects. It's can you get the stuff out there and show in the ground so people can see it, and I think that's the big turning point. Once you can bring people to see this technology in action, it really convinces people that this is the right option.
Okay, and do you know where to go to get those right now?
We do have some support, but you always need more connections, and I think like these kind of events, as well as the opportunities for living labs, help bring these people and the right partners together. So you can make these connections for investment, for projects, and for people. Okay.
Luke T, what about yourself? What do you need?
It's interesting because I think we kind of similar positions in where our businesses are. You know, we're now 14 people. 18 months ago we were 4, so we're at a huge growth rate. And it boils down to finding really good people. Giving them the facilities to be able to do what they need to do, and then finding the funding to be able to enable all of that. You know, even with a great team, a great technology, and sort of the traction that actually gets you where you're going, you still need the benefit of being in the right place at the right time. And it's interesting you said that about 8 years ago, because I don't think we would have made anywhere near the progress we have made in the last 2.5 years if we'd come up with this idea even 5 years ago. 10 years ago, definitely not. The momentum within the industry, because of these net zero targets, the collective ambition to try and actually decarbonize, has meant that our government is putting money towards innovation projects. We've definitely benefited from that. And from a private investment perspective, investors can see the returns on a horizon that is acceptable, 10, 20 years. And that wasn't true 5 years ago. People weren't willing to put their money behind net zero focused technologies because they couldn't see that they would get their money back. And I think whilst it's challenging, I think it's possible, but moments like this where we're able to actually talk about our technology and what we need, that hopefully we're raising enough awareness that we start the ball rolling even faster.
Okay. I think we're going to have just a little bit of time for a couple of questions from the audience. But before I just go to the audience, always like to talk about failure, because failure is where you absolutely learn. I've been working with startup businesses for 15, 20 years now, and failure is always the crunch point. What have you learned along your journey? What is it that you've learned? Luke?
I think it's like the rapid prototyping. So the quicker obviously you need to think a plan about how you're going to approach something, but it's actually the actual doing, failing quickly, but in terms of a prototyping sense. And I think it's the doing part that you need to really focus on. Yeah, getting examples in the field. Okay,
and has it not not gone well in the past?
I think for me, we would have liked to have moved a bit quicker and get stuff out there quicker. But again, I think it goes back to the point of timing. There's numerous examples of people moving before the market was ready in the hydrogen sector. So now you can see the momentum going on. So from our perspective. But I think we could have moved a little bit quicker, in my opinion.
Okay.
So, what have we learned?
Always a difficult question. No. Always a difficult question.
We basically work on the basis that, try. Just try. You can't fail. You can only learn, right? So, like, I work with a bunch of really, really good scientists, really, really engineers, and you can't fault someone for trying. We design for success, and when it doesn't pan out exactly as we'd intended, we take the lessons learned and we try again. And we've had a lot of successes in what we've done, but we've also had a lot of failures, and you've got to take the bits of success from that and move it forward into your next iteration. That's not just technical either. That's like commercial relationships, partnerships, premises, how you've built your space out for your team. Yeah. There's so many things that you learn in that short period of time that you just need to sort of roll with the punches, so to speak, and make sure that you minimize that error in the next time you do it.
So fast start, fast fail.
Fail fast, someone said it earlier.
Yeah. Okay, so have we got any questions at all? Okay, gentleman here, if you can just wait for the mic to reach you.
Thanks for a nice presentation. I'm Mona. I started from Effectis Group. We are a fire safety testing and engineering company. Safety. So we are going through, but I have a question from the look in the middle. Just when we are using the term safety for the hydrogen, what is the criteria for us for this? Because in my opinion, safety, perspective opinion, they are saying hydrogen is not safer and it is not more dangerous than any other fuel. It's just in education. It means people don't have enough perception about that. All it's safe.
Okay. Hydrogen.
Yeah. So just in our products, we basically form a chemical bond with the hydrogen, so it means it leaks a lot less. So basically, it's a chemically bonded form. So you don't have that fugitive hydrogen that can lead to global emissions, and also in terms of explosive environments locally. So that's kind of, but yeah, like you agree, you design the systems to be safe, but the idea is you kind of minimize those areas for error, essentially. And I mean, like with our systems, because they're sort of modular systems, you haven't got a big tank of gas there where if there's a leak, it's all going, or you don't have that. You can overcome those problems, and the materials that we use, you can essentially keep them on the desk, and nothing will happen to them. So they're very sort of safe to handle materials. But yeah, no, it's completely right. Like you say, there are comparisons with other. We work with lots of dangerous things every day, whether that's fuel or batteries or various other things. Lots of things can go wrong, and the idea is you design out all of those failure mechanisms through prototyping and working with people in the industry who leverage those expertise. And we're a small company, and we want to access manufacturing expertise, safety expertise out there. And a lot of the projects we're on have safety as partnerships in those projects.
Okay. Well, we've got one question here. I think we've only got time for just one more question.
Hello, my name is Niall from Highways for a startup at Cranfield University. And my little observation is that the universities are actually kind of failing in this industry, insofar as they're not producing enough engineers and scientists and educating folks about the potential for hydrogen. And we started up in the summertime, and we've actually got vacancies. We're having an extremely hard time filling these vacancies. There's not enough women in science and engineering. In hydrogen, it's despicably bad. And I just want to understand what you guys have experienced in actually filling vacancies, getting good quality people, and actually getting more women in science and engineering.
Okay, so
Sure, yeah, I absolutely agree with you on the fact that there is not enough women coming through, sort of through STEM programs, and it all sort of starts with the grassroots applications, right? You know, getting people interested at the younger ages. In terms of filling vacancies and finding the right caliber of staff, it is extremely challenging. I think the universities have been slow on identifying hydrogen as a huge growth prospect. I don't know what they're teaching, right now this year, but we are doing our best to pick up engineers with similar experience, predominantly oil and gas. And one thing that is going in our favor is that actually now people want to leave oil and gas. There is a huge number of people who are looking for opportunities in hydrogen to try and, because they see that as the future, rather than the oil and gas industry, which is sort of deteriorating or will deteriorate over time. But we're not the only ones that are seeing that goal either. For example, the BPs and the Shells now have huge hydrogen sectors. So we've got small startups like ourselves trying to deal with competing with some of the biggest players in the market for a limited resource that's available.
Yeah.
Could I add? Sorry,
very quickly.
go on.
Just running out of time.
Oh, yeah. So, I think it's coming. I think once people see the deployments in the field, like hydrogen buses, once they see it. So, there's a young woman that wrote to me because she was doing her UCAS application, and she was asked the question at school, what is one of the things that will change the world over the next decade? And she wrote about hydrogen. And she was then she put that into the UCAS form for a university application. So it's kind of that inspiring projects that will help those younger people see what hydrogen can do. That will funnel people through to the university application stages, and then on to and the industry is struggling with hiring enough people into the sector. So we do need to set that straight.
Okay, I know we've got a skills session later on. Simon Barnes from University of Kent is going to be leading that, so perhaps we can pick it up then. So one final kind of killer question. When I'm long retired, 10, 15 years from now, what will success look like for you and the technologies that you're developing? Luke.
You can obviously talk about the usual business metrics and saying, global deployment and everything. But for me, it's all about impact, whether in terms of environmental impact. Are you saving, 1 million tons of CO2, 10 million tons, 1 billion tons? It's those metrics, those milestones that really motivates me. There's also the social impact, so being able to provide energy to lift people above the energy poverty line as well. And I think for me, the thing about hydrogen is because you can use local renewables to produce local hydrogen for power for local people. And I think that's that local-based narrative that's working really well with hydrogen. And that's something that motivates me.
Okay. Luke, just quickly.
Similarly for us, we set up Supercritical to be able to help decarbonise the hardest to abate sectors.
Yeah.
20% of the world's emission coming from things like steel, cement, chemicals, and with all the best ambitions in the world, electrification of those sectors is going to be extremely, extremely hard. And hydrogen is a shoe-in for that. And Supercritical's technology, delivering high efficiency production with high pressure delivery, is a shoe-in for those industries. They're the ones that are most sensitive to cost, and we want to be able to solve their problems. So for us, success in the short term, by 2030, looks like getting operational deployments on the ground to give industry confidence, because I'm very confident that will open the floodgates to an order of magnitude more deployments to actually start to reduce that 20% step by step.
Okay. Thank you ever so much. Really inspiring. Great to talk to you. You guys are around all day, so you guys can talk to you. I think the future does look really bright. There's just two examples of some great companies. There are others out there. We're seeing them across the Manufacturing Technology Centre. But thank you very much, guys. Really good.
Thank you.